Hi, welcome to week 3, lecture 1, part 1. In this lesson we're going to cover section 3.1 in the text, and this is where we start looking at the semantics of the system SL that we've been covering so far. So let's just start out with an important distinction between what are called truth values and truth conditions. So in our system we only have two truth values. We have true is one truth value, and we have also the false. So a sentence in SL, where remember we designate a sentence just with a particular kind of letter, A, B, C, or we can also use subscripts as well, like you see down here, A subscript 1, A subscript 2. Each of these sentences of SL can only be either true or it can be false. But there aren't any other third truth values that we have. So we have a logical system that has two different kinds of truth values. But these are different than what are called the truth conditions. Now, the truth conditions you can think of as belonging to the sort of compound sentences. So the conditions under which a compound sentence will be true. So if you remember, we have the symbol here, which we call a conjunction, and this is very similar to the natural language connective and this truth table here tells us what the truth conditions for a conjunction is. In other words, it says that depending on how the truth values are combined, the component sentence or the complex sentence will have a particular truth value. So the truth conditions specify the truth value of the complex sentence given the different conditions of the atomic sentences. So say truth conditions are the truth value of the complex sentence given the truth values of the atomic sentences. So you can think of as truth tables encoding truth conditions, and one condition or one scenario is, for example, when A and B are both true. So there's another way of another concept that we call a truth value assignment, and that is intuitively what I just called a particular condition. So one truth value assignment is you can think about it as a row in the truth table. So if we have two sentences, A and B, then one truth assignment is to have A be true and to have B be true. In other words, for A to have the truth value T or true, and B to have the truth value T. And under this assignment, the conjunction gives the complex sentence the truth value true. But then there are also other assignments, namely when A is true and B is false. And under this assignment, conjunction gives the truth value false for the complex sentence. So a truth value assignment is an assignment of truth values to each sentence of SL. Now the way I've just said that in this sentence means that we have to assign a true and a false for each sentence letter in SL. But remember, if you remember from our last lesson, there's going to be an infinite number of different sentences in SL. So we have A1, A2, A3, we can also have B1, B2, B3, C1, C2, C3, ad infinitum. So strictly speaking then, if we were to build a truth table that encoded every single possible assignment for each sentence, then we're going to have an infinite number of different combinations. But luckily, any given sentence in SL is going to have, in most cases, just a finite number of sentences. So we won't ever have to look at these infinitely large truth tables. All we're going to have to do is build truth tables out of the sentences that we actually see in the given sentence of SL. So if we have a sentence, for example, like A and B, then all we need to do to build a truth table is consider all the different possible truth assignments for this given sentence. So the only ones we have to look at are the sentence A and the sentence B. So how do we go about building truth tables then? Well, the first thing we need to figure out is how many different kinds of combinations do we need to consider? That is, how many different possible truth assignments are there? And the answer to this is always going to be 2 to the n. So where do we get this from? Well, a given sentence D can either be true or false, right? So there's only 2 truth values. So if we look at negation, for example, the truth table for a sentence that is negated will only require 2 rows. Why? Well, there's only one sentence letter, and there's only 2 possible assignments, namely that the atomic sentence D is false, or that it's true. So a given sentence D can either be true or false, so there are only 2 possible assignments. But suppose we have a sentence that has 2 different atomic sentences. So this will be sentences like not D and E, or D. So if we have this sentence, for example, this one only has 2 atomic sentences, E and the sentence D. So there's only 2 different, since each of them only can have 2 different truth values, then in total there's 4 different combinations to work out. Right? The case where both of them are true, the case where one is true and the other one is false, the vice versa of that, and then the assignment when both of them are false. So let's see, complex sentences with 2 atomic sentences need or have 4 possible combinations. But notice once you jump up to complex sentences that have 3 atomic sentences, we're now going to jump into 8 different possibilities. And rather than spending time writing this all out, let me just actually give you an example that is already listed in the book. Okay, so if you notice here, here's an example of a sentence that has 3 different sentences, atomic sentences. We have A, B, and C. So we said when there's 2 atomic sentences that we're going to have 4 different possible assignments. When we have an additional 3rd atomic sentence, then now we're going to have 8 possible assignments. So 8 possible different combinations of assigning true and false. How do we get that? Well, there's all the scenarios where we have all the 4 different truth assignments for B and C when A is true, and then we're also going to need to have all of these assignments again when A is false. And that we get when we look here. So if you look at this block of the truth assignments for B and C, we just end up repeating that down here. And in fact, that also, if you just look at within the truth assignments for just B and C, we notice that we keep repeating the assignment for C for the scenarios when B is true, and then again for the assignments when F is false. So there's a pattern that you can think of when you build a truth table. You take one sentence, one atomic sentence, and you assign true and false. And then if there's a second one, well, you can think of, okay, C can be true and false when B is true, and then you can repeat that again, right? So C could also be true or false when B is false. So we end up repeating this part so these two truth assignments for C get repeated here, once for the conditions when B is true and once for the conditions when F is false, or when B is false. And then when we have a third atomic sentence, you can think about all of these possible assignments for the combinations of B and C. There's going to be one block of them for all the scenarios when A is true, and then you're going to get that same scenario again when A is false. And notice that this is going to be exponential, right? So if we add a fourth atomic sentence, then we're going to have to repeat this whole block for the scenarios where that fourth one is always true, and then we would add that one again down here for all the scenarios when that fourth sentence is false. And so you can see how this builds exponentially, because you're always going to have to be doubling up from the previous number of truth assignments. So that's where we get 2 to the n. 2 is the number of truth values you have, so true or false, and then n is the number of sentence letters you have. So when you have 1, 2 to the n is 2. When you have 2 sentence letters, then 2 to the n is 4, so you have 2 to the 2, and then when you have 3 sentence letters, you have 2 to the 3, which gives you 8, and so on. Okay, so that's how we have to figure out how many different truth values we have. That's how we figure out how many different kinds of truth assignments we need in order to be able to build our truth tables. Okay, so I'm going to stop it there, but in the next lesson we're going to go over an example of how to actually construct a truth table.